Today's lesson really isn't anything new when it comes to exponential growth and decay. We're just adding that application piece. So before we get started with that, I want to give you an opportunity to review being able to identify whether a function represents an exponential growth or decay. So I want you to take a look at these three problems, enter them into Edpuzzle, and then check to see if you are correct. All right, let's check this. Knowing that our equation is y equals a times b to the x, and we had said yesterday if b is greater than 1, that means growth, and if b is between 0 and 1, that means decay. That being said, b here is 3.5, that is bigger than 1, so it's growth. Then 0.25 is less than 1, so this is decay. And 0.955 is also less than 1, so this one is also decay. Now, looking at this next one, we have the amount of caffeine in a person's bloodstream decreases by about 25% per hour. What percent of the caffeine is remaining after 1 hour and 5 hours? And a lot of you are probably thinking right now, well, I don't have an initial value. Well, this is where it makes a good opportunity to make a table. So if we do t representing time, or time, just writing time, and having the percent, when time is 0, when we start, we are at 100%. It decreases by 25% per hour. So if you look here then, after 1 hour, we're going to be down to 75%. Now here's where it gets tricky, because after 2 hours, it's 75% of, we have to take 25% of that 75%. So if we think of it like a 75 and do 75 times 0.25, we're going to get 18.75. That's how much it's decreasing by. So if we then take 75 minus 18.75, we get 56.25. Now this is where that rate comes in. If we take 1 minus 0.25, which is how we would find our b value for the equation, we get 0.75, which means we can use that to say 75 times 0.75, and we get that 56.25%. Well then, after 3 hours, we're going to take that 56.25 times 75% of it, and we get 42.1875%. Then after 4 hours, we still have to go to 5. After 4 hours, we're going to take that 42.1875 times 0.75, and we get approximately 31.64%. We'll round at this point. And then for 5 hours, we'll take that times 0.75, and we get an answer of approximately 23.73%. So what we're looking for here is the 75% and the 23.73. It's not as easy as just subtracting 25% each hour. Now the next type of problem. We have the population in Tokyo, Yokohama, Japan was about 28,447,000 in 95 and was projected to grow at an annual rate of 1.1%. Predict the population for the year 2016. So first thing we need to do is come up with our b value. We're growing, so we're going to take 1 plus 1.1%, which is 0.011, which gives us a b value of 1.011. Our initial value is 28,447,000, so we have that y is equal to 28,447,000 times 1.011 to the x power. When we talk 2016, you figure 96, 97, 98, 99, 2000, 2000 plus 16 more years, that's 21 years. So we're going to do x equals 21. So if we rewrite this, I'm just going to fill it in here to be 21, and then we can go ahead and punch that into our calculator. 28,447,000 times 1.011 raised to the 21st power. We hit enter, and we get 35,794,041.74, so we'd say 042 because you can't have 0.74 of a person. So people. Your job now is to go ahead and give this You Try Problem a shot, enter your answers into Edpuzzle, and as always, bring your questions with you to class tomorrow.